We have created this to-do app. It can do a number of things. So we can move stuff here, done, start. We can add a new to-do item, do this. We can edit to-do items. So anything you would expect from a to-do app. And then we also showed that we can have a chat interface. So I can say, add a to-do to write another video script by Friday. Then I can submit the same to the chat, and the chat will actually now insert me this to-do item here on the side. Here it is, and it's even the correct date. So now we are exploring how do we get to this. And so you see it has kind of a traditional part of the app, which is what you are used to with menu buttons and what have you. And it has this chat app. So it's a bit like an iceberg. And we have the part below the iceberg, which is this app here. And this chat here is actually just a remote control on this. So we will split this in 2 further videos. In the video now, I'm going to explain you how all of this works in the traditional app, which is a prerequisite to understand how we can build the AI layer on top, which we will do in the next video. Welcome back to the MeshWeaver channel. I'm Roland, and we are helping you to understand and manage your data. And today we are going to look at architectural principles behind a business application. Okay, now before we go into our to-do app, it's probably worthwhile just looking at a few core architectural principles, and I also give you the advice, read a lot on those, so you have a few core architecture patterns. There is a lot of literature written, but it's also interesting that you just see what is important for you. So for me, this is always, I want a cloud-first design, so I want to be able to host my things in the cloud eventually. Of course, I develop locally on my own laptop, but whatever I do on my laptop, I should later be able to ship to the cloud. I want to, from the beginning, have the idea of a distributed system, so I don't want to say I have to first consolidate the whole company in my system, because this is boiling the ocean. It will never work. So it's better to just think of working in distributed systems. And then I want to be able to do things asynchronously. So you can think, if you order a t-shirt, it's not that you kind of stop your life and you go down to the mailbox and you wait until the t-shirt arrives and only then you do the next thing. But you order the t-shirt, you go on with your life, and 2 days later you get the t-shirt. But then you also need tracking mechanisms to understand, hey, I haven't actually received the t-shirt. And then you have to go and call the store and say, hey, give me my t-shirt. So it's a little bit of difficulty, but if you don't follow this, you will have a huge infrastructure with a 5% load and the rest of the system just always waiting for stuff. So I highly advise you to be able to do things asynchronously. Then if we look at the architecture patterns, again, there is a lot written. So today we are just going to look at one thing, which is actually from Uncle Bob. He's called Bob Martin, and he has written a book, The Clean Architecture, which shows that the centerpiece is this entity layer. So this is your data model. Then the outer shell, these are the use cases. So whatever you do with the data model. And then in the outer shell, you have a way to access the data model so that you can ask me for data or layouts or whatever. And then in the outermost layer, we have the infrastructure concerns. And maybe just to point out one detail, you see that the database, it's an infrastructure concern and it's not the centerpiece. So I hear from a lot of people who don't actually work in IT, I hear, and then I put this database in the middle. Don't do that. You will also not find any kind of formal architecture that supports this. So database, it's always an infrastructure concern. And it's also just needed for failover. So normally in cloud-based systems, you have the state always in RAM, but only if you have to redeploy the service or if the service goes down and you need to restart, then of course you need some kind of data storage where you can reload the data. It's something you don't need during development. During development, you will never save any state out. And it's something that you also just need whenever you go live with a system. So we go now to VS Code, and in VS Code, let's first look at the 4 projects. The main project that we are going to look at today is this To-Do project. This is where all the core architecture is living. Portal is just the one that I start, which provides me the window around it and the presentation framework. But let's look now at the To-Do. So normally I always create a folder called domain. You could call it differently, but my suggestion to all of you is always factor out the domain in a separate place. If this was a production grade application, I would even put the domain in a completely separate project. Then I would create a project MeshWeaver app to do domain, for instance, and put this in. So this is really the core, and because it's the centerpiece of the architecture, it's also the one that's most difficult to change. And if you ever do a project with me, for instance, you will notice that we spend most of our time designing this domain model. So this really needs to be perfect. Now let's look at the main class here, which is To-Do item. So first of all, this is a C# construct called record, which is essentially used to create exactly this kind of situation where we have a class which just contains data. So it's now too technical to go into all the details that we have. But you see then a record consists of properties. So here we have an ID property, here we have a title property, we have a description property and a category, a due date, a status, a created at, updated at. So it's really the full data content of a To-Do item. In this sense, it's also business knowledge. This is not IT knowledge, this is business knowledge, because it models your own business domain. And it will also be your data vocabulary, because now you see the first thing I have done is I have created these comments around it. And it's very natural. At some point you have to say what these things mean, you know? So now, which options do you have? Of course, I could now open, for instance, a Word document and I could write down in the Word document, but then this stuff is more or less lost, because who will ever find this Word document? Where am I even going to store it? And whoever is using this application will probably not find the Word document anymore. And so where do I write this? So the best thing is always write comments very, very close to where the data content is stored, you know, because when you then modify this, you see, so if I decide I want to delete title, then I just delete the whole thing, and then also the comment is deleted. If it's not so close together, you already have a problem. Oh, I delete now the title, but then I have to update this diagram. I have to update this Word document. It gets very difficult. So easy is when you have everything together, then it's very easy to do. Then the second thing is that you have to have certain constructs to annotate what it is. So for instance, for the ID, I want to annotate that this is my primary key. So a primary key is something that uniquely identifies me this particular instance, because I will have to say delete this To-Do item. I might have many To-Do items with a similar title or a similar name. And so it would not know which one I want to delete. So we need really a unique identifier, so that we have a unique way to speak with this. You can look at this like, for instance, your social security number or anything that uniquely identifies you, because there might be other people with the exact same name that you have, and so you need something that uniquely identifies you. So all this we will denote with just with this key attribute here. And then, for instance, I can say, hey, I don't want to actually expose it, because it will be some wild string, and you know, users, they get nervous when they see wild strings that they don't understand. So I can then just say browsable false, and then it will just disappear from all my views. Then I have the title. this is self-explanatory. Then I have the description, and here we see another attribute that I can put. So this attribute word is not even so necessary, so I could also just omit it. And here you see then I have this UI control, and then I can actually say, how do I want to have this thing displayed? Because if I have just a string, it will put me a normal string field, which is normally some smaller box. But for description, I want to put a little bit more text. So I can say, make it a text area. And the text area will bring me a little bit a bigger thing in the UI. So it's also quite convenient, just if you are experienced. So for instance, if you see me doing these data models, I just do it intuitively when I design it, because I have already a bit the dialogue in my mind that I want to create with it. So I would automatically write something like UI control text area to say it should be something a bit bigger. Then the last concept I want to introduce you to is the dimension concept. This comes from data warehousing. Typically, you divide into dimensions and facts, and the facts are grouped by dimensions. So a dimension could be something like a product type, a category. So normally it's some kind of discrete set of things, and I should pick one of the discrete set of things. Could also be a currency, and then you see I shouldn't just be able to say currency ABC or name of my grandmother, but I should always pick something of a valid list. So in here we have our to-do category, and then when I go to to-do category, this is the other part. So you see it jump now. You can control click in VS Code. If I hit control, then you see then this gets bluish. I can click on it and I just navigate here. So this is also a very good way to explore data models. So you are much better off looking at something like this than, for instance, looking at some word table or whatever, and it's then inflexible. And here it automatically jumps up so that I see where I am. So we can then see what a category is. So normally I differentiate between something like a system name, which is also the key, and this has to be stable because I will actually use it in my data model. So you see if I have here a string, then this string will actually refer to an actual value that I have to have in the DB. And then normally what I do is I want to keep this stable, because, you know, otherwise if I change it every time I need to update my database. So this is not very nice. And then I have a second name, which I call here the display name. So it comes actually with this interface iNamed. So iNamed is just anything which has this display name. And so if you use this iNamed here, then the system will pick it up and it will automatically use the display name to denote things in the UI rather than using this name. And even if you hand out name and display name at the beginning the same, but display names, normally they change over time, because then, you know, if you work in a company, your management has ideas, they want to call things differently. And so then you are quite happy if you have this distinction between a technical name and really the thing they see on the reports, because then you can just go and change this and this is not relevant. And then eventually here it's the description. So this is a very, very important field because we are going to work with LLMs. And you see LLMs, they want to always have some context. So I will ask the LLM to map to to-do categories. And then what I have to do is, in these descriptions, I can then say, for instance, video filming, because it's part of my profession, it's a work item, and it's not a leisure item, and all these things, you have to put them somewhere. And so the best thing is if you can just put them in the data content here. Now we looked in a lot of detail into our domain. So then let's look at the rest, what we have. So on the one hand, it has created us a lot of sample data. So this is the way in which I like to work with sample data during development. So you see, if this was a production grade system, you would actually factor this bit out in a separate DLL that you would not deploy when you go live with the system, because this would then be your database layer. But during development, this is a very good way of doing it. So you just create these inline, well, actually not you, but you let Copilot do it. And then you have just these instances inline, and you don't need to worry about reading data files and the like. So I really like this way to put this. And then the last bit we have is the layout area. So this is a lot of code, but it looks like more than it is, because it's just sloppy code that formats this page. So we are speaking about this page, and it has a lot of pictures, and it's, as always, code that renders something like that is a bit difficult to read. But you see already we have these pictures in line. It kind of guides you a bit through it, so you can find visual anchors to this picture. And actually you also never need to know how to put this, because Copilot will put these icons for you. Again, you need some rough idea how to read this, but you don't actually need to understand how to write this code. You just need to know what to tell Copilot to write. So now let's look at the last bit. So we saw now we have the domain, we have the layout areas, and we have the sample data. But where does it all flow together? And so it flows together in this attribute. So an attribute, it's something that I can put, in this case, it's put on the assembly. So the assembly, it's essentially, it's the compiled project, so it's a compiled DLL, the compiled package here. And like, if I pack a box with dishes, and then I write, this is box with dishes, put in kitchen. So I can put a label on the box to know what's inside. I can do the same with a DLL. So I can put a label on top and say what's inside. And so here I put the label and I say inside is the to-do app. And in the to-do app, the most important bit is this configuration. And if we look at this configuration, we see it is a hub configuration. We will look in a second what this is. And it assembles us all the data together, and it assembles us all the layout bits we have together. So this is essentially where all of this flows together. But what is now a hub? So we go back to our architecture picture, and in the hubs here, it gives an address to your data. So in our case, actually I just called it app to do. So if we go to the running application, you notice this address here. So it's app to do. And this last bit is the layout area. So we are looking now at the to-do list inside app to do. This address, it's quite sophisticated how to choose it, because it denotes your data partition. Now in this very example, we don't care so much. It's just a showcase. But normally it wouldn't be a good idea. For instance, if you edit to-do items for 1 million people, then you wouldn't put them into one place in our mesh. But you could then, for instance, differentiate by person. So you could have to-do/Roland as address type, or to-do my project if you want to store them by project. But you see the choice of address, it chooses you the partition, and this depends on, now in this case of this to-do app, it depends if we want to-dos by project or by person, or what's the scope of what we do. So it's already a content exercise how to do this. But then we have hosted components in there, and then eventually we can send messages. So a message hub, as the name implies, its primary purpose is I have a message and I want to send the message from A to B. So the way this works is then as follows. So here we look now again at this process. Here we have, for instance, these to-do items in pending. And now I can click on start. So let's remember here we have team meeting prep. I click on start. And then what's happening is now you see team meeting prep. It moved down here into the in progress, and it has now the button done. So the question is, how can we achieve something like this? If it's the first time that you think about this, and probably it's a very cultural question, but if you grew up in this kind of Western society, as I did, then we have a tendency to think in a very imperative way. So we tend to think, I click the button, then it has to be deleted from pending, then it has to put into in progress, then I have to change the button. So this is called imperative. Imperative means I give orders, I say delete yourself from here, put yourself there. With this thinking, you will never succeed to build these APIs. So it's the same claim. Maybe you have children, and if your thinking is you have to tell everything to the child, dress like this, go there, the child will die eventually, because you cannot possibly foresee everything that will ever happen, and at the end of the day something completely different will happen. So then it's much better to look at this from a completely different angle. Now, going back to the code, we see now how we start this layout area. And so let me go to the very beginning. So here you see everything starts with a stream. And it's a different way of thinking, it's a different way of looking at the world, but it's a very important difference. So to me it was even life-changing. I completely changed also the way I behave towards my children and everything. And the reason is that, you know, you don't plan anything, you just observe what happens. So you say, I don't load the to-do items and then loading is over and I have something there, but you say, I consume a stream. And whenever something happens in this stream, I get a new set. I can parse it again. And when something happens again, I get a new set. I can parse it again. And if you start thinking in this way, then we come to this sequence diagram. So you see, I subscribe now to the to-do list. So this is from the GUI. So this happens if I click on here on the to-do menu item, then the portal says someone wants to look at the to-do app. Then what the to-do app does is it subscribes to this stream and it generates the layout area. So it actually renders the whole thing, because actually what we don't want the data, but we just want the view. And so always host the views next to your data. It's very good practice, because then you only ship the actual visible bits from the data. And then this whole view is shipped back to the UI, and then if I don't do any action, then nothing happens. So the portal hub then just renders it, so this gives me then the HTML that I actually look at in the browser. Now you see, from the browser I will actually click a button, okay? And so the button press, it's actually just sends, hey, someone pressed the button. So it's all that's reported. And then what it does is it sends a data change request. And in the data change request, I just say someone wants to move the to-do item from pending state to in progress state, for instance. Then it updates the to-do item here on the to-do hub, and it just changes this thing. But then, since I have subscribed to a stream, it will automatically put the new data state to the stream. It will automatically render a new layout area, and then the UI will hash, and I will see this. Okay. Again, I launch an event. I want to change status updates. It sends back to the layout area re-renders, and now it has sent me the next picture. Now, which events do we have? You see, there are only very few events involved. And this is also something I see a lot on YouTube, that then they tell me you have to now say create to-do event command or change to-do event status. And if you do this, then before you blink twice, you have 600 events created. And in my opinion, it's just bloat. So my suggestion to you clearly is ignore these thousands of YouTubers who preach this and just don't believe them and just don't do it. Because now actually we need only very few things. So we need a clicked event to track the clicks. Then we need a data changed event and a data change request. I'm going to show you this in code again. So if we go to the layout area where we actually render all these things, then we can just look for data change request. And here you see for instance, this is submit to-do update. And in here, I just have the updated to-do item. So there I can just, change the status of the to-do item or whatever I want to do. Then I create my new message. So my new message is I request a change of the data. So it's data change request. And I say I want an update. And my update is I want to update this to-do item. And then here is where the hub gets visible. You see here hub.post. So post means I want to send a letter. And again, I don't need to know where my target hub, which is this to-do application. So if I click here on the address, it's very simply new application address to do. So it's the address amongst which we have this exposed. But I can just address it. So it's the same as when you go to your own post office. You just have to write the address on the envelope, but you don't actually need to know where the city is or where this person is living, nor how you could ever reach this city. None of this is known to you. So it's a complete cross-cutting concern which is done in the background. So you can just say, I have a change request to this to-do address, and I want to change this to-do item. With this is actually the only thing we ever need. And with this, we come back to this picture here and then it will re-render the dialog. Why is this so important to understand? It's so important because changes in the app are as simple as submitting this change request. So it means that I don't necessarily now need to have a button doing this change request, or the change request could be triggered from outside, or I could even have an API. Let me maybe illustrate this. I will just for now mimic that I'm actually two users. And so you see now I can essentially say I add a new to-do item and I say go shopping again. And then you see on the other user, it has now also inserted it. It's now very robust, And with this kind of imperative logic, you don't get this, because with this kind of imperative logic, I would have programmed update my own UI, but no one would have thought, oh, there is actually a second user and the second user also wants to get this. You may say now, well, I can first update one UI. First of all, you will write 10 times the code or 100 times the code. It will never be robust and you never have this data replication. And just dealing with the state that the data is more or less out of date, It's very, very complicated because then you come into a whole discipline of how to sync data and the like. It's much easier to always see that you have one common data state. And in our application, so going back to the blog, it's very clear how this happens. So we always have this architecture that we take the to-do item, we do a data binding to the view model. So there is a whole section written how this works. But in a nutshell, this is just something that knows, and when I have a button, then click me, and then I change the to-do status, and then it goes to the view and back. So this is all you need. And like this, you get it to work independently of how many user interfaces you launch here. So all of this stops mattering. And this, of course, is then the basis for the last part, which we do in the next video, where we will show you how to attach now this whole thing to the large language model layer. But you see, in a nutshell, I gave you already the idea that it's actually rather easy because you just have to trigger these messages. And so it's just a question how I can trigger the messages now from the chatbot. And with this, we will end this video. I hope to see you in the next video where we will show you how to attach all of this to the chatbot. Happy weaving.